Good evening, everybody. My name is Manny Khadilkar, and I work as a solutions architect at Kong, focusing on really helping customers deploy Kong into various application infrastructures. And I'm here to lead a session on governing API management and connectivity with Kong today. So most people attending the Zero Trust conference are undergoing some type of transformation, and transformation is just something businesses have always had to deal with. And today, almost all aspects of businesses are transforming to digital and internet-based solutions, and it's all happening from the ground up. The developers are building applications for their organizations, and they're racing to get software and services out to the market faster. And we saw that from the poll. I mean, most of the folks attending this call are interested in getting their products out faster. Um, the reason why this is happening is you can create more resilient applications um, as you kind of move to microservices, and you can add features to your applications faster. And so, as organizations are trying to compete with smaller startups who are on a level playing field with cloud-based infrastructure, it's being able to drive that adoption faster and drive usage faster is generally a win. So, where does governance really play a role in all of this? Because usually governance can imply, a slower development process. Um, well, the reality is that, your developers are going to build governance, like authentication and authorization and controls. They're going to build it in because they have to in order to get a product into production. However, each development team will probably govern their APIs in different ways if they're all, separate teams building microservices, unless they have a common platform to do this with. And so, what most organizations are looking to do with a technology like Kong is to give developers the tools that they need to govern their APIs using a standard authentication and authorization framework, and then control which applications and services those developers can expose with roles-based access control. And then the organizations usually just want to get out of the way and let their teams build. So the other topic that comes up is as these applications are getting more and more decentralized, one of the growing needs is to have a zero trust network, which really means that every service on the network can only talk to other services on the network if they are trusted, which means they need to have a valid PKI certificate issued to them from a central policy server. This gives your developers a secure network to build on so they don't have to layer on network reliability and security into their code. So let's look at the next slide to get a little bit more context. And I'm sure folks have seen a variation of this slide before, but it really outlines the whole reason why we have things like pizza teams and microservices. And it's because we want to move faster. And so obviously the way we move faster is by making the services on this diagram, which are the circles, smaller and smaller. So as you can see, when you move to the right, you get smaller and smaller circles. And that's because our developers can build those services faster. They can deploy them in a more distributed manner to add resiliency and add features faster. Well, that definitely like aligns with the agile, sprint methodologies that we see out there today. But it's pretty clear that as you move to the right, your control and visibility is going to go down. So imagine if you're juggling, if these circles were balls, if you're juggling the one on the left versus all the balls on the right, it's going to be much more difficult to handle this paradigm on the right. And that's what a lot of customers and businesses are finding out. They're finding out that governance really needs to be compatible with this new paradigm. And so if you're building APIs as an interface to the microservices on the right hand side of your screen, then the API gateway, which is really a table stakes component to decentralization, it needs to give you the capability to govern all the dots on the right hand side of this picture. And it has to be able to deploy alongside your application code. And then if you look at all the lines that are actually connecting the circles in this picture, think of that as the network. And so you can see that the number of network connections are going to go up exponentially with each new set of microservices. So let's look at these connections in a little bit more detail. Um, as your microservices grow, you're going to end up with three types of connections. One is a connectivity at the edge where organizations can provide a nice API to their external customers and partners. This one is pretty well understood. The second type of connectivity is between applications and organization within an organization. And this is to take advantage of the usability and functionality of APIs so everybody doesn't keep reinventing the wheel. Um, and finally, there's the in-app connectivity. So this is the service-to-service connectivity where there may not be an API, but there needs to be a reliable, trusted network, which your developers can use to make service-to-service calls reliable and secure. In all of these scenarios, your developers are going to need the autonomy to build without having to overlay their own authentication and authorization, network reliability, failover, all the things that they're using to kind of provide governance to their services. And they need to be able to automate it because it'll be very difficult to iterate quickly enough to handle the new paradigm to compete without having that automation. So Kong's vision is to provide a unique platform to help wrangle this problem. We call it the service connectivity platform. And the three key ways that Kong helps is by enabling decentralization with the API gateway and the mesh, and then allowing your developers to layer in the standards-based authentication and authorization over a reliable network without inventing their own methods. And then finally, to be able to publish the APIs to an API catalog or developer portal so that other developers can consume those APIs. And that's really one of the main goals of creating APIs in the first place. So I'm going to jump in and actually show you a couple ways that you can use a gateway like Kong to decentralize your applications and keep tight governance controls for role-based access control in place. So let me switch screens here and just show you my Kong environment. So I actually I'm going to log in as a super administrator here. And when I log in, you'll see that I can actually see all the different workspaces in my Kong environment. But as a developer that's working on product X, I want to use Kong to handle some of the common policies so I don't have to break them into my code and to handle routing for me. But I don't really need to see all the other workspaces, right? So I need role-based access control. So what I'm going to do is switch to another browser so you can see what it looks like when I log in as a developer that only has access to the product X workspace. So as you can see here, I can only see that workspace. Think of a workspace similar to like a namespace or a realm. And so if I look at this workspace, now I can see all the services for my product. I can see all the policies and plugins that I'm offloading to Kong. And then I can also see all the routes that I want Kong to take care of for me. Now, what I'm going to do is I'm going to actually expose my API and so that I can make a request from my REST client. So if I look at my REST client here, I have a route called route underscore product X that I want to be able to expose through Kong. And right now, that route is not available. So what I really want to be able to do is just programmatically set up Kong so that I can expose my service and work on it. Well, Kong gives you a great way to do this through the admin API. So if we actually switch screens here, you'll see a little script that I've written that's going to expose my service, add common functionality like caching and rate limiting to my service, and then then I'll be able to actually build it and test it. So let me switch over to my terminal And I'm going to go ahead and run that script. And now if I go back and refresh the screen, what you should see is a number of things change on the screen because there are some policies that I've added. So as a developer, I'm able to quickly configure Kong. And now if I go in and test my API, you'll see this message change on the right. And it actually says no API key was found in the request. So if I actually add an API key, now you'll see that my request works. So I'm able to test some functionality in Kong as well as start building my APIs. Um, so what I just showed you was that I can configure Kong using the RESTful API. And the reason that's beneficial is I can do this as I'm iterating and building my application, even if my development environment's being rebuilt every day or every hour to enable automated delivery. And I'm only going to be able to touch my own workspace, no one else's. So let's switch gears here a little bit, and I'll wear my operator hat. And let's say the developer has built a few services already in this workspace, and now I need to move um, this configuration into my testing environment so it can be tested. Well, I want to take the exact same configuration and move it over, except for some environment variables. With Kong, you can do this using a declarative configuration, and you can synchronize a Kong configuration from a development environment to a test environment. So it becomes very easy to promote between environments and enable that automation. Um, then I can automate the testing of my code and deliver Kong's configuration, alongside my actual microservices as code. So here's a sample of a declarative file that you can send to Kong, and it will actually target a particular workspace. So in my case, I'm going to target the product X workspace that I just showed you. And I'm going to build a few services and expose them via routes, as well as add a couple plugins. And so what I'm going to do is show you how that works. So if I look at Kong really quick, you'll see that right now, I'm looking at my test environment without the new changes making it in there. But if I clear my terminal here and I run my declarative deck sync, it's going to create 22 new objects within Kong. And now if I go back in Kong and refresh my screen, you'll see that I now have the same environment that I was just testing in development. Now it's ready for me to use here with 3 new services, a couple new consumers. So I can now test my applications, and Kong will handle the routing and policy for me. So the benefit here is that you have a very highly automated iterative environment. My ops team can deliver Kong alongside my application, and we can use role-based access control to ensure that the code is only for a specific team. So each workspace is segregated. Um, this really allows each team to work autonomously and deliver functionality faster because they can move the common code to Kong, they can expose entry points and automate this process into their different environments. A side note here on declarative configuration, you can also configure Kong using an open API spec. Um, and you can use the declarative configuration to perform things like drift detection and rollback mechanisms so that you can make sure that Kong is running exactly the right code that you want it to be in each region or geographic cluster that it's running in. Okay, so I just spent a bunch of time showing you how you can use a cloud native gateway like Kong to offload common policies and routing. But what about the governance piece? How can I layer on security? Well, I'm going to show you how you can use a standards-based approach like OpenID Connect, which is already built into one of my endpoints in my environment. And so what I'm going to do is just navigate to that endpoint, and then you'll see that I'm going to be redirected to my Keycloak identity provider, and I have to authenticate before I'm able to access that endpoint. This is going to show you the authorization code flow, but keep in mind that Kong will support all of the different OpenID Connect flows that are out there today. So let me switch gears here and just bring up a new. So if I go to this particular endpoint, you'll see that I'm redirected to Keycloak. And so now I have to actually authenticate with the correct credentials in order to be able to access the API that Kong is protecting. So you'll see if I put in the wrong password, I'm not allowed to access the endpoint. But if I put in the right password, then you'll see that Kong sends me back to the host, back to the service that Kong is layered in front of with a token so that additional upstream validations can be done. Now, similarly, if I go to the same endpoint in an incognito window, but I use another username, and this user is not authorized to access this endpoint. What you'll see is even though I authenticated with the right username and password, I'm actually not authorized, so I'm forbidden to access this endpoint. So just a quick example there of how you can use Kong to um, layer on governance controls for runtime API requests that are going through the Kong proxy. I showed you the OpenID Connect plugin, and the benefit of that plugin is that you can have a standardized way to govern your endpoints wherever they're deployed. Um, so the next piece that I want to talk about is, one of the fastest kind of areas around governance is the concept of zero trust. So basically, I don't want my services to be able to communicate with each other unless they explicitly trust each other. And the goal is to give your organizations and developers a network that they can build these services on to ensure they have network reliability and zero trust. So they don't have to build MTLS and reliability into their code. And so I'm going to show you how I can enable zero trust across multiple regions with a Kong mesh. I actually have a counter application. Let me just show you a diagram here. And so this application is actually, I'm going to, from my browser, be accessing this application's front end right here through a Kong proxy. And it's running in the GKE East cluster. And what you're going to see is I'm going to increment the counter, and it stores the counter in a Redis, but it's going to store that counter in the Redis in the East region as well as West region. And it's going to bounce back and forth. And the reason it's able to do this is it's running on a Kong mesh that handles all the routing and network reliability. But then what I'm going to do is I'm going to actually change the traffic permissions to show you how you can easily control the traffic. Because the reason this works on the Kong mesh is each one of these sidecars has a PKI credential that's being issued by my global control plane. So let me go ahead and show this to you. So here's my entry point to my application. And if I hit this increment button, you can see that everything is working, and I'm bouncing back and forth between GKE East and GKE West, where I have both infrastructures running. Now, if I hit auto increment, this is where you'll see it start bouncing back and forth because I've told it to load balance between these two data centers. And what I want to do is I want to take a quick look at my traffic permissions policy. So I can go into um, K9s, which I'm using to look at my control plane. And if I look at the Kuma system, this is where my control plane is for the mesh. And if I look at the traffic permissions, CRD here, you can see that there's one right here called allow all default. And so if I take a closer look at that and zoom in, you'll see that by default, I'm letting all the source services communicate with all destination services. Well, I don't want that. That's not very secure. So what I can do is normally you'd go in and find, in the Kuma or Kong Mesh user interface, you'd be able to check each service and explicitly define which services are allowed to talk to each service. But since we don't have a whole lot of time, I'm just going to delete this traffic permission. And what you should see happen is on the right hand side, you're going to see my app stops working because I've basically told my network not to trust any services. And so now the benefit of this is I have a single place where I can control every one of the connections that we saw earlier in my presentation so that my developers don't have to build this into their code. Um, okay, so this is just a quick look at the traffic permission policy again, so you can see, how I deleted that traffic permission policy. Now, I know we're getting close to the end, so I'll kind of look at the chat here for questions, and I can also join the room one for any follow-up questions. But I just want to say thank you for joining the webinar today.